Hello and welcome to another fine evening of Rust. Today we're going to keep playing Hypersonic, the Bomberman game, working on a robot and doing a bit more AI programming. We're going to do a breadth-first search today, we think, or whatever ends up becoming of my code. There's a lot of setup work to do today though, and I'm going to quickly get this clash of code here because we always join because it looks like it's almost full. So we do this first, a game that shows about Rust. If you just joined us first time, it shows about Rust AI programming. Hey Sinclair, we get started with this clash of code in 5 seconds. It's usually timed, so I'm going to be concentrating on this. I don't always win. Lowest code size. Oh, it's golf, so I can take my time. Ooh, in planet Calador, 1 year lasts 11 months and 1 math 17 days. Months and days are named by their index, 1, 2, etc. The year can be negative or positive, but like on planet Earth, it can't be 0. For some obscure reason, the months 7 and 10 have 7 additional days. You are given a date, and you should give the date of the next day. Wow, this one's hard! Man, for code golf, this is just going to be a matter of getting it working. And there's going to be ones where I have to lap over to the next day. Yeah, this sucks. Okay, so we need to go the next date. So what do we say? We have the next date, and we're going to say how many days are in the month. Days in month. And I'm going to do this very slowly first. This is code golf, but I don't really care at this point. And months 7 and 10 have additional types. If month equals 7 or month equals 10, then we have... How many days in the month we have? We usually have 17. But in this case, we have 24. Else we have 17. This is the number of days in the month. So we're going to say day plus equals 1. If day is greater than or equal to days, greater than days in month. Can't believe that guy's done already. He's much faster than I am. We're going to say then month plus equals 1. If month is greater than 11, year plus equals 1. If year equals 0, year equals 1. And he failed all of them. That's why he's done so fast. So what do we have to say the next date is? We have to say year, month, day. So you're going to have to make all those mutable. You, month, day. So let's make them mutable. I hope that makes sense what I'm doing. Let's try one, look for syntax errors. Hey, it worked all right. Summer is coming, so expect... What the hell do you mean expected nothing? How can you expect nothing? That's not fair. 2001 6-1, okay. The months 7 and 10. Okay, so what's it expecting? 2007 6-1. And I gave it 6. Oh, I forgot to reset the date. Silly, silly me. Day equals 1. That would be the issue there. Super slow. And what do we have? I'm tempted just to submit this. Oh, except we have an error. Expected 1-1. I did the same thing here. Month equals 1. I'm tempted to just submit it because we're not going to win code size anyways. And if we get in front of everybody else, but yeah, we're not going to, so it's not going to make any difference. Let's just play around with the code size minimally and see what we can do. We'll clean it up a little bit. I'm not too interested in getting it too tightly down now. We get this, we can get rid of the print error. And we can probably do the mapping right away, but we're going to leave it exactly like this. It's hard to say if we're getting rid of the parse input. We can just make it smaller to just be P. And we could do mapping, but let's just do I. And we can get rid of that one bit there. The I32, we can make it all go away as well. So it's at this point, making a map is not likely going to be any faster or he's smaller, I mean, because it involves a lot more characters. It'd be the correct way to do it, but it doesn't involve, it just involves more characters. That's the big issue. Now, we don't have to use a standard I/O because we only have one. We don't care about the result. We know that this is actually, this is into is the shortest way to get a string. Should check a random one again. And now let's just make the input line just be L. I'm going to call it Q just so it's easier to see. Q dot split, and days and month, I'm just going to call it X just so it's smaller. And we could probably do this right here and just get rid of X entirely and stick it inline. I think this needs a bracket here. I don't know. Well, let's test again. Let's see how we're doing. So this has made it quite a bit smaller. I'm not sure how much smaller we should actually make this. You can't do split white space. That's actually longer. Let I, let mut. Could we actually simplify this into a vector of 3 items? I wonder. But no, we probably, because then all of these would require indexes. I don't see anything obvious to reduce this with right now. I don't know if Rust allows this. Does Rust allow inline things? Let's find out. Plus equals 1. Does this evaluate to a value in Rust? C style? Probably not. No, it doesn't like that. And that makes sense, because that's actually a horrible thing to do in code. Plus equals 1 if blah blah blah. Mon plus 1 day equals 1. If m is greater than 1, m equals 1, and plus m equals 0. Alright, I don't think we can remove any of these conditions. And all we can do now, I think, is reduce white space. I think that's all you need to do. Collect vec. Alright, it's fine. Collect vec, collect vec. Alright, so let's just collect the white space. Everybody else is having troubles with this. Let's just start collecting white space and see what happens. I'm going to leave that in there. Hope we don't need the spaces in there. Just keep checking this again to make sure we don't need spaces. Get rid of all the obvious white space first. Alright, this is the easy stuff. I just do this in stages in case we screwed up because I don't have a good rollback on these things. Rust is not the best language for code golf, obviously, but we'll do our best here. Looks like we'll probably do well because other people just may not finish. Alright, where else can we remove spaces? Inline spaces. Let's get rid of as many of those as we can. Okay, we can probably get rid of there. This is codinggame.com. I can post a link right after, just after I'm done focusing with this one. And I think we can get rid of the spaces here, make this super cryptic. Everybody loves cryptic golf code. I really wish the golf competition actually didn't require me to do this. I really wish the golf competition had like a built-in white space stripper and even variable renamer, because this to me isn't the challenging part of golf. The challenging part of golf is to actually reduce the semantic load of it. But I've still not seen a site that actually checks the semantic size as opposed to the syntactic size, or as opposed to the variable naming size. I could probably get rid of this, or this, or this, and 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 probably this and this. So this code is awful now. Under code review, I would reject all of this, obviously. And any more spaces I can see, let's just pack this all together. You can't even see it on here anymore. Get rid of 2 more lines. We're down to 331. Let's play all the test case, make sure we haven't broke anything, and then we'll submit this, and we should be good to go. And this sounded harder than it really was, but it wasn't that tricky. It was just reading it in the direct order. And there's a lot of test cases, and I think they're really well submitted. Alright, so this one, was this fun? This one was exciting. Difficulty? I think this one was actually perfect for golf. This is exactly what we want, and the statement was very clear. Test case relevancy seemed good. Let's just submit that. And I'll throw the name of the site over into the chat for... Oh my, did you expect me to pronounce that name? Let's just say Asaf, okay? Asaf. Welcome to the show, Asaf. We were just doing the warm-up. I always do this warm-up here. And so we just did the small one. And of course, but I beat him. I'm happier. I got quicker than the Ruby guy. And so obviously Ruby's going to be a lot smaller. And this is just tiny packed. Wow, and they did something... And see, this is what I mean about actually an algorithmic golf checker, semantic golf checker, and yeah, Sinclair, that your name is certainly using that, but you told me how to say it though. So I mean, this is what I mean here is that this obviously it reduces it more. There's actually some cleverness here that goes well beyond what we did in space stripping. His Ruby one is shorter, not just because he has lower syntax, but because he's done something actually different. And to me, this is what we want. This is, I think, what I'd love to have a golf site that exemplifies that type of thing. Like, you actually had something semantically smaller than what I did. I just stripped spaces, and that's just silly. But that's not the way most golf works, and that'd be extremely hard to compare. It's like you want to have a built-in refactoring that says, oh, that'd be cool if you had like a golf name where you could actually say at the end how to strip white space and all the renaming that you would apply. That'd be cool. So you could encode it right in your code. And then the game could actually compile it in both ways to make sure it works. And then you could actually have a fair comparison. So you would have still readable code, but then you still have the stripped version. I think that would be really cool. Alright, so let's let this run out. I think we're going to do well here just because, unless all of these guys have it working and they're just trying to remove some more code. But let's go over to what we're actually competing on today. And we're over here on Hypersonic. For those who are watching the show for the first time, we're going to be playing Hypersonic today, which is a Bomberman type game. And we're going to spam the people first with the name of the show. Copy this over here. Copy the link location. And we're going to go off in the chat. And we do it over here. Oh, we're in the wrong chat. Let's go to General. Playing Hypersonic live. Here we go. And we're going to zoom this one in again so we can make the screen bigger. And you see these buttons here, they're about to disappear because we don't need to see what they are. Just going to go over here and you can barely see them. We just need to hit play. This makes it a bit bigger. I've requested, I think numerous people requested some way to make this part of the screen bigger. All you have is this full screen option. Well, it isn't so good because I don't want the whole screen, I just want part of the screen. And we're going to turn on the external editor again. Where's the external editor? Uh-oh. There's something missing. We're missing the external editor. This is bad. Let's reload this. There's an editor down here, an option to change the external editor. That's not good. We use this a lot for the show. We rely on that. Let's go ask in general. Where did the external editor option go? Is there an extension? Oh, right. Oh, right. There's an extension. Let's figure out where that was. That was Jasper's external editor integration. Somebody at Firefox support suggested I reset Firefox, so I foolishly did that, and that removes everything. Alright, here we go. Firefox. Please don't make me restart. Please don't make me restart. Alright. Good. Let's see if it's there now. Alright, here we go. Settings. It's probably going to make me reload now. That seems fair. There we go. External editor. So, for people not sure of that, what we're doing is that this editor here, not to mince words, sucks. It's small, it's slow, it has the wrong font, and it's one file. So what we do is we use, and let me get that link again, in case you're watching this the first time, you can see the link for this. I have some resources here. This applies to more than just Rust. There's this tool from Jasper, the external editor integration, which lets you use an external file and it uploads it, which is much nicer. We also use ePen's Rust source builder, which is specific to Rust, which lets us build a proper Rust project, which it collapses down into a single file, and then we upload that. And why do I have messages for me? Load. And I turn off my proxy for this, even though I don't know what those are. So I turn off my proxy when I'm using this. Usually I use a TorGuard proxy for most of my web browsing using SSL, and it's helpful, but for this it interferes with too much of Twitch, and sometimes it goes slow and I don't want to lose the stream. And I think pretty much since I'm broadcasting what I'm doing, there's not a big fear of being tracked at this location. So let's select a file, and this is going to be source evening rust private, and what is Hypersonic. And so this is the single file here that we're building, and we'll upload this one. We'll upload the file, and this will just run in the back. Anytime we make changes, it'll upload that. And so if we play the game now, our current bot is ridiculously stupid. We kind of cheesed it into this league. You'll see right away, all our bot does is place one bot and wait here the rest of the game. Our bot is actually smarter than this, except we realize that in Silver League, you can get by there. Oh, Natsun, where's that? That would be really cool if I can hide this internal one. Does it make this screen bigger? That'd be really cool if I could like rearrange the screen. And oh, what's our? We ranked 3. That's pretty cool. So in that competition, we ranked 3rd. I'm really curious now. I'm gonna go open this in another window. What were the actual results of this competition? The small one. I don't know, the clash. I mean, probably because other people did finish, and they tried things like. Okay, so we only had 2 more that finished it. Oh yes, the log window right would be really helpful. Okay, so most people never finished it, I guess, in this one here. And he finished it in Java, and Java is even harder to play code golf with. Yeah, Natsun, if you can find it, I might actually enable that, and that would be kind of cool to get working. It'd be really cool if I could just make this get bigger, right? There, you can make this. If I just move this further and further over, that'd be cool too. And then I can get this screen even bigger, just so you guys can see the game better. But I think the resolution should be high enough you guys can see what's happening here without me having to go full screen. Most of the other games I can go full screen, you can mainly see it, but since the update's on the left side here and the game's on the right, hidden by this part, hidden by half of my broadcast screen, you don't see it. And unfortunately, full screen is you don't have an option to say full window, it's just full screen. So we lose this thing, and now we actually have to write a real bot. This is where we are. Our bot, we don't simulate much. And the way our bot's going to work, and we've talked about this last show, is we're going to do a breadth first search. And what that means is on the possible turns. So given any current position, given our current position, how many moves do we have in the current game? Now, ignoring the fact we can't do them all right now, you can either move down, you can move right, you can move up, you can move left, or you can stay where you are. So there's 5 moves. All of those have the variance of you can drop a bomb first. So this actually gives 10 different moves. Now Petroso was saying that he only uses 5. He only drops a bomb if he sits in place. And I might take a variant of that. What I think I'm going to do is I'm going to take his basic logic, but for the first move, say, let's just experiment all 10 for the first move, because that doesn't cost us as much, but maybe we'll do the same thing, but we can play with that a bit. And then you walk through the tree, is that if I go up, now let's enumerate all the moves again. If I go left, up, right, down, and you're going to walk through this to a level of 5 or 6 or 7, and you're going to let the bombs explode, and you're going to actually track the score. And the one that results in the highest score and you not dying is the move you take, the initial move. And then you reevaluate this every turn. I mean, there's a whole bunch of links here. Console maximizer. Let's check out some of these links. Live dangerously, clicking links from chat. Oh, it's on coding game. That's not too dangerous. Okay. Alright, I'm gonna just bookmark this one and I'm gonna check this out later. I'm not gonna mess around with Firefox during the show because I'll lose a lot of stuff then. I've had problems crashing it before. But thank you, Nuts, and I'll check this one out and I'll see if I can tweak it. Because I'm actually interested if I can tweak that. I'll look at his script and I'll just tweak it to get this thing occupying a bigger part of the screen. That might also work. Alright, so let's go off to the code. Where are we in this code? I'm using, oh, more updates. No. And I don't need these updates. I wish they'd just fix the indent one. The indent one is with the brackets and the coding one. We also have this RLS plugin again. It just doesn't work for us, which is unfortunate, but we'll move on. So I say this is the code, this is the main code, and you can see basically here, it's just weird, okay? We just do this. We just cheat. We don't do anything. We just do the basic moves. And I'm going to see what the status of that is, and I'm going to remove the CRUD. Alright, so we're going to remove this CRUD now. Our basic strategy is stupid, so let's remove this. We don't need the iteration. We don't need bombs. We might want iterations. No, that's part of the state. Screw it. We don't need iterations. And we can remove this hard-coded strategy. Remove this. And this goes back to the old strategy then. The problem with the old strategy is that this was written for the Wood League. And the Wood League, you didn't get hurt by your own bombs. So if we play this one now, and you can see that we can do this. We can do clear and cargo build. If we... iter +1, get rid of that one. What have I done? What have I done? What have I done? Save spots. Oh, this is all this one too. So this is all just part of our fixed strategy we don't need. So this is the one where if we play this one, we're going to immediately die from our own bomb. We do go to a good place and bomb. We don't walk out of the way. Right, so watch what happens. We go, we place a bomb. Right down here. We're over here this time. No, wait. Yeah, no, we just die. We don't watch our own bomb. And so this is where we actually have to simulate the game. We actually have to do... And unfortunately, this is a little bit of work now. We can't interactively do this. What's scary in the Silver League is how far we got with our stupid strategy. Okay, so... we have to build the simulator now. That's the key thing we have to build now. And what I mean by the simulator is we have to be able to step through the game, apply a move, update all the bombs in the thing. What the game it would do itself, we actually have to update the game itself. And that's a little bit weird. I don't want to, because when you do a move in the game, like if you're here, and he calls a move to go down here, it takes the shortest path over there. And I don't know if I'm going to implement that in the simulator. We're just going to assume it's always one step at a time, because that's how our game's going to work. And we'll just go that way. And we'll do mainly of this mostly offline. I can just minimize some of these windows. Alright. So our main class is state. And this is where it's going to get a little bit interesting. We need to have a simulator. So let's create a simulator class or a function. And I'll make it take a state. Simulator.rs. And let's see what we do. We're going to do or use state. I've got so many imports in different languages. Use state star. We're going to add the simulator to the lib file. And then we have the one function. We have a key function that says, okay, what function do we have? And we're going to build tests for all this along the way so we can test it offline, and because we're doing Rust correctly. So it'll be a public function step state, and it takes a state and mutable state. And it's going to modify that state. It's not going to return a new state. Ideally, if you didn't have to worry about processing power too much, you'd ideally want this to return a new state object so it keeps the current one pristine. And we're not going to do that because we know we're going to have to modify the current state. And we're actually going to go one step further, which I'm going to leave out for now, is we're actually going to have to pass a second parameter called undo, which will be a vector of things to undo the step. Because we know in advance that we can't afford to clone the state. Now this may sound like a premature optimization, but if we look at state again, if you look at the variables it has, the size myId, not a big deal. But these entities are large. These are all the boxes and all the bombs and all the players. This could be 30, 40 items, and it has to copy them all and it has to create a new vector. Even worse is the matrix of cell type. This creates one new vector, and I think this is like 19 times 11. It is only a raw copy, but it does take a long time, so while it may seem like a premature optimization, we're going to actually go along this lines knowing that the copying of the state, this cloning of the state, is simply going to take too long for us to use any level of depth. So we're going to undo it. Although I am tempted, I'm really tempted to do it first with the cloning and just see what happens. And it could be an option. We could just tempt it with the cloning first, because I don't think we lose too much in terms of extra work having to do it again later. But we'll still do step state. Step state's still going to take a current state, and we'll let the caller do a clone. And so what do we have in step state? And this is the one where Rust becomes a real problem for us, is that we cannot iterate through entities of a state and update them at the same time. This is really ugly, and I really don't like this about Rust. And you've seen this in a lot of the other shows. We have these every time we hit this function where we have to modify the game state, we have the exact same problem. It's very difficult to do, and because what happens here is that we want to iterate over entities. Right? We're going to iterate over these entities, and we have to find all the bombs, and we have to decrement them by 1. But if a bomb explodes, then we have to modify it. And so basically we're going to go through, create a temporary list or something. I don't know how we're going to do this. And it's really an efficiency thing at this point. How do we do this efficiently? And let's just start writing it any way possible. The only way I can think to do it correctly is just to clone that thing, which really sucks. Well, let's find all the bombs. All right, the first thing let's find all the bombs in the entities, because those are the ones we're going to update. So we're going to do let bombs equal state.entities.filter entity.what equals. And what are the entities? Where is entity defined? Entity type bomb. And this is actually, we're going to enumerate this filter, and this is going to be an index. I mean, this we don't need the index comma bomb. So we've filtered them all out, and now we want to do filter it, and we want to collect this into a vector of whatever it's supposed to be. This will collect all the bombs, and this is a duplication. I find this a needless duplication, but what can I do? And then we'll say for bomb index in bombs. And see, now we're no longer borrowing the state, so now we're free to update the state here. So the bombs, we're going to have to actually load something in here first of all, because the state, our bombs, we don't have the countdown yet. And let's go find out what the countdown is. So when you place a bomb, it counts down a certain amount. And this must be part of the state. Param 1 and param 2. And param 1 and param 2. Does it say what these are? Param 1. I guess we're just going to have to debug this. It doesn't tell me which one param 1 is. That kind of sucks. So I'm guessing one of these parameters says what the countdown on the bomb is, but this actually means it's not described here. Oh, here it is. Why is... Well, there's something wacky with searching. Good job, Firefox. Param 1's right here as well. For bombs, number of rounds left until the bomb explodes. And this is a little bit tricky. What exactly does number of rounds left mean? Does 1 mean it explodes in the next round? We'll find out, I guess. We're going to simulate this a bit. So these both have pub param 1 and just going to make this I32 and pub param 2, and this is I32. We're just going to do them exactly that way. I'm not going to attempt to give them aliases or other names. We're just going to happen to know what those are. And this is going to have to be in the entry area. When we read in the bombs, we have param 1 and param 2. And we can simply do this. We can simply do param 1, param 2. We call them param 1 and 2. We'll just simply pass them over. Okay. And so now what we do is we're going to say we do state.entities bomb index dot param 1. Param 1 was the round left until bomb explodes. Okay. Minus equals 1. If state.entities bomb index dot param 1 equals 0, and we're going to have to clear this from the board. Clear from grid. And we have to explode. And we can actually, since we have no borrowing yet, I think on the states, we can safely explode the bomb in a different function. Function explode. Yeah, this is going to have to take a copy of the entity then. That's fine. Bomb. This will be an entity. And I'll take a copy of it. It will not take a reference to it. We'll just do this. Explode. State.entities bomb index dot clone. No, let's give it an index instead. Just give it a bomb index. Bomb index, and this is going for probably a use size. Because this will probably be a use size. We'll explode the index of the bomb. Let's do that. And I won't clear out the entities from the list because that'll be too annoying. Alright, so this explodes the bombs, gets rid of the count. We have to implement explode, and that'll get rid of boxes. And we'll just, like I said, we'll just leave them in the list. because this is only triggering on 0. It's not going to be less than or equal to 0. It's going to be exactly equal to 0, so we can just leave these in there. It'll clean up the state and get rid of it. Yeah, let's clear from the grid. So state.grid.set state.entities bomb index.position, and this is cell type empty. So we assume there's nothing left on this bomb now. Though actually, I'm tempted to say, I think we need a new state type. We need some way to know. Actually, no, we'll just leave the bombs there. How are we going to calculate the death of the user? There's two ways we can calculate the death of a user. We can either temporarily mark the board with flame, or for the given user, we can simply take their position and look towards all of the bombs and see if we actually have one there. And actually, we'll do that. That's fine. And actually, we should only clear it from the board when it actually hits -1. Because that's when it's truly gone. And this depends on how we're doing our algorithm. We'll clear it when it's at -1 so that we can still look for it on the side turn we're on. And if you're watching and wondering why don't I create a reference to this entities, it's because I can't. This is a borrowing system. Again, it's something I complain about with Rust, and you've heard it a lot, and nobody's offered a solution to it. You have to do this redundantly a lot, because if you attempt to do a reference to it, you're going to create a borrowing check error. Alright, so we count down all the bombs, that's all we need, but now in the exploding bombs we actually need to go through and figure out what the bomb hits. And I think we had some of this code before, but let's just do it again. We're going to take the position at, and the bomb explodes in every direction. And let's see what code I had before that was very similar. We had this offset stuff over here, which we can reuse. And we had the bomb range. Bomb range is now dynamic. And yeah, this is a little bit weird now. Let's just copy this one over. I don't care if it's simulator different syntaxes. So first off, we want to do for I in self dot. No, this is state. These are all states. Sorry, these are all states. State. That was all state. State dot entities bomb index dot param2 was the range, and this is where it's really unclear. The range does not include itself. It means away from itself. We said that in strategy over here. The bomb range is 2 when it actually lists 3 in the thing. So it's 1 less because the spot it considers itself. And so here we can safely go up to param2 because this is going to be 1 less than it. Okay. And I'm going to do each of the offsets separately because the loop is discontinuous. For direction and offsets. Let flame position equal state.entities bomb index position. Start there. Dot clone, I guess, or these are probably already copy types. We'll find out. It'll whine to us otherwise. And we probably don't even need that. We can say let CFP current flame position equals flame position plus direction times I. And I hope that does the right precedence. And now we're going to check the type of the cell at that. match state.grid.get CFP. And we should give it a default. I think we said it has a default. We call it get def, yeah. And we'll make it a get def a wall, because it's going to stop at the wall. Get def cell type wall. Okay. So I have to walk away from the gun. So we have a match. We say cell type wall. And this is going to break out. This is going to cancel this loop because it didn't find anything. It hit a wall and stopped. Cell type empty. This is good. It keeps going. Just do nothing. Cell type. What else do we have? We have a box. We have a bomb. Oh, this is going to get weird. This is going to get weird. And let's just put a 2D one here. Chain reaction. Cell type box. Alright, so it's the box cases we care about. We want the boxes to go away. And I guess the bomb needs to have an owner. If state.entities index dot, do we even care about that? We care about dot owner equals state dot my ID state dot score plus equals, do we get one box, 1 point per box? We're gonna need to have a score. We don't have a score in here yet. Public score, and we'll just say my score. I won't track the other player for now, although we should. And now we're going to clear the box out. The box goes away. And actually, the box doesn't go away yet. Wow, this is going to be difficult because the box doesn't go away until the end of the round. And this has an implication if there happens to be a bomb on both sides of the boxes, they'll both... Actually, no, it doesn't matter. We can remove it because even if the flame on the other side stopped it... let's just ignore that for now. Let's just do this. Let's state.grid.set CFP cell type empty. To do delay to end. So we might have to accumulate a list of things to actually clean up, to remove from the board. Let's actually just do it this way first. Let's check the basic ones. This clears it out. This empty, it sets the score. And if it's a bomb, it doesn't matter. We're going to track that one anyways. Bomb chain reaction, we have to do that. State.grade bomb indexes, and this updates the state. We clear the state. So now we're going to write a test case for all of this. And our test cases are another folder. We have tests, really. We have a test directory. There it is. We have a strategy test directory. And we're going to make a simulator test now. I'm just going to save this one as another file. Save as simulator, RS. Simulator. And we're going to test stepping. We're going to use a 10 by 10 grid to make this simpler. We're actually going to make it 20 by 10 just so it doesn't actually... Now, let's just do 12 by 10 just so it doesn't screw up the indexing. Get rid of these tests. And yeah, I'm sorry. It's a lot of work to watch these things set up. It's the initial code until I see something running, all this initial setup work, and all I really want to do is test the thing. So we're going to put a game box. I think we can leave these. Let's just take the most basic one for now. Game box at 0.3, 3, and let's add another one. Add entity. And this is going to whine at us because we haven't set the parameters of these things. This really annoys me. So this is actually param1 0, param2 0. You can't like partially initialize these things, and we'll create instruction, but that's okay. We'll just live with it. And we're going to add a bomb. We're going to leave the owner as 1, and we're going to put the bomb at 3, 5. That's within range. Param1 was the countdown. We're going to put the countdown as 3, and we're going to put the range as 3. Okay. So that should be enough. And what we want to do now is we want to do simulator.step. Step. Why did it not pop up? Step, state, and state. This will step 1 state, and then we can insert equals. These entities are added in order. So we're going to say this param1 now becomes 2. State.entities. Hello, moderated seal. Welcome to the show. We're writing a simulator right now for the Bomberman, Hypersonic. Param1. So this is what we expect. If all of what we've written so far, we expect when we step to state 1 that the parameter there goes down 1. And we do it right here. And so we should be able to do this. Cargo window clear and cargo test. And I forgot how to run particular test, but it doesn't matter because we have to clean all this stuff up first. Oh boy, simulator, what did we do wrong? Something horribly wrong on line 32. Collect dot. What does it not like about the collect? Filter dot. What's it upset about? Anybody know what it's upset about? Let's just do collect and just say over here vec usize. Maybe that gives us a better idea as to what's wrong. Doesn't look like it. Made it different. Point. No, okay, we have to input point. Maybe missing extern point. Yeah, I still don't know how to group things together in Rust. It looks like every single class I have to import on its own if I do it this way within individual modules. Alright, so this is going to get annoying to me. Entry. G38. Param1 is 0, param2 is 0. That looks good, so we have to add those. Those have the parameters. And simulator, we can control click on this stuff. Yes, we can. Offsets. Now, why is this not working now? In the strategy, where do we use offsets? Only one of them has the and on it. No field types, that's correct, because it's entities. Entities. That's the same one. Again, it compiles twice too, which is kind of annoying. And this probably requires an iter. Just do a new filter. And errors, and what, and. The type of this value must be known in this context. It is known. How can it not be known? What am I missing? Alright, this one has to be a map. Index, comma, we don't care about that. Index. What else do we have? Maybe that's the whole problem. That one thing could screw up the whole thing. No field entities. That's the same thing, entites. You notice it's compiling twice. I don't know why it's doing that as well. Some weirdness with Rust. Missing field, my score, and initializer state 29. Alright, so this one is not considered changing except a tuple. Oh, yeah, these are tuples, not parameters. I always get caught by that. I still have entity. I'm terrible at typing entities. So these are all the same error. It just compiles the same thing multiple times. Oh, come on. This is... The syntax for the functional map stuff in Rust is not friendly. It's really not easy to use, and I don't know how long it'll take before I get used to the fact that filter wants to take a reference to it, not a copy. It's just... See, and this is exactly what I mean. It suggests one thing, and then it takes another thing. Let's take a reference to this, and a reference to whatever the hell this is. I don't care about the reference. And again, this is the exact same problem. I get really frustrated while trying to use this high-level stuff in Rust, because by the time you figure out the Rust, it's just simpler to just do a normal for loop. What the hell is supposed to be the reference here? Entities are. Entities, what are entities? Entities is a vec of entity. And you want to filter based on a reference. I want to enumerate. But enumerate is probably not passing the right type. And if I do its suggestion, it's probably just going to whine some more at me. Or not. I honestly like this. Having a reference with a reference inside of it. I mean, whoever got mad that C made fun of it pointers to pointers to pointers is obviously going to have the same problem with Rust. But even in basic code, you have references to references of references, and it's really annoying. Simulator. This was in strategy. We need to add... Yeah, we're just going to stick it in here at the end. Before we create a cleaner type, I'm just going to stick these on at the end. It's probably an easier way to do this, but so we don't have the duplication. But this isn't test code. I'm not that concerned. And it's just the same thing again. And I just have no idea. I just have no idea what I'm supposed to do here. And so I give up on this syntax and just go back to a normal syntax. Let bombs equal vector usize new. Actually, this has to be this. And now we're just going to go for index and 0 dot dot state dot entities dot. See, now we can probably enumerate this, but I just don't care about the headache. I just do state dot entities dot len. if state.entities index does what does not equal entity type bomb continue. That's the easiest way to do this. Bombs.push index. So we know that works. I don't think I have to worry about the references there. Vec is private. It's probably what I want. Cannot oral mutably, that's fine. But so like I say, this was really, it's really trivial to write this code, and I still have a problem with this. I just don't know when you're iterating. If anybody can tell me, is there a sane way to do this? Tell me how this code works, because every single time I hit filter and map, I have the exact same difficulty, especially when using enumerate. Without enumerate, I can usually do it, but the moment I do enumerate, I can just never get the syntax right. I never know how to iterate these things correctly. I know what I want to do, and I just fail to get it working. And the suggestion the compiler spits out are totally useless in that regards. So we have to test. We gave it a poor name. Step. Where's step? There's step. And somehow we can do specific test. I forgot how. There we go. Step simulator. So we're in a simulator. So it actually works. That's good. We do that. And we're going to do it again. 1. This gets it down to 1. And this gets us down to 0. And this is going to have to do more. We're going to check that right away. What we want to check now is that the box is no longer on the grid. We're going to leave it in the list of entities because it's cheaper to undo later. So assert equals cell type empty state.grid.get 3, 3. Now just to verify, just before this one should still be cell type box. We're going to verify it here so that we're not doing something weird. Expected 1, yeah, of course, expected 1 parameter. And we're going to write a get xy function. It's easier than always specifying the parameters. No, Rust does not allow overloads, which is unfortunate. So if you have a get that takes two different syntaxes, you have to write 2 different functions. xi32, yi32. Uh-oh. Left box, right empty. And this is on... You got an empty one. Well, that's not good. Let's see where it's empty. Let's start the game. Let's check sure it's still at the beginning of the game. It's not empty. Oh, right there it's empty. So we already screwed up. Add entity here. Hasn't set our state correctly. The grid has not been set up. I thought we did that before though. Add entity was bomb, and we don't set a box there. Weird. Well, let's set the box up now. Cell type box. Else if ent.what equal entity type gamebox. Alright, so we stepped it. It blew up the box. That's exactly what we wanted. And we're going to change the simulator to do a second box here to make sure it's okay. We're going to add a second box. And so I don't have to change the indexes. I'm going to add it afterwards. We're going to add a second box, and this was at the bomb was at 3, 5. So we're going to do 8, 5. It shouldn't reach there. It's too far away. 8, 5, and this is still going to be a box. Okay, and we should also check that the player's score is 1 state.myscore. Player score is 1. Check all of this stuff. Good, that's all correct, except for the to-dos we have. And we have some to-dos. I only checked one bomb, I'm hoping it's okay. We have the chain reactions, and we're supposed to delay this to the end. But this should give us enough to actually start writing the recursive descent. So we have enough of a stepping function. We can actually, oh, step it, find out what happens. Step it, find out what happens. And I don't know how we can test this locally. Oh, we need to know if we die. Dying is bad. So let's do something. We check if we die based on the current board state. And we'll do that on the simulator as well. We'll make a second function. And we'll just make it a separate function for clarity because we don't need it. Check dead. And we need a state, and it doesn't have any mutable. Moderated CO. Yes, they are. No. Wait, I don't know. I think they might block it. Range. Explosions will cause a box to be destroyed. Items will be destroyed. And that stops them. So items should also be destroyed. You're absolutely correct. So let's destroy the item as well. Players do not stop it. Alright, so let's add the items because I think that one's enough. Cell type item. I don't even have an item, do I? Well, that's wacky. Where's my cell type? Item. We're going to need a cell type item. And I'm going to add it down here as well. Again, this should probably be read now. Now that we're adding everything to the grid, entity type. And we're going to have to change our stepping strategy as well because our path, we're not actually going to use it anymore, so it doesn't matter. So item. Item. Simulator, if it's an item, what do we do with items? They just get destroyed. Importantly though, these both cause it to stop searching. Same delay to end. This one's not so tragic because, I mean, this item doesn't actually stop the flame because if there's a bomb on the other side, the flame's just gonna it's gonna calculate going through. But since we have bombs on both sides, it won't make a difference. But for the box, the reason so this doesn't matter here. We don't need this to do. It doesn't matter. But the box we need to delay to the end because if two people blow up the same box, they both get the points for it. So let's add two more things to here. We add one below the box to make sure it's stopping it. Entity, we're going to say an item. We're going to add an item, and the bomb's at 3, 5. We're going to have the item at 3, 6. And then we're going to add another box, game box, at 3, 7. And this will ensure that those items still exist. Cell type empty at 3,6, and 3,7 is still a box. Entity type item, what do we do wrong there? Item range or item count. We had 2 of them, that's fine. Let's just destroy both of them. Now we should do this. We should change this to a match now. Item range. Oops. Item count. Just gonna call it, and the grid doesn't need to know what else is there. The grid's enough to just do that. I think these have commas after them. Yeah. All right. Oh yeah, this annoying things. Don't do anything in that case. Where's this one? And what should the items be represented as? Well, let's put a little tilde mark there. Why not? Those are items for debugging. Yeah. Oops. I probably screwed the whole file up. Variant not found. Where is this? What did I do wrong here? I will just item range, that's right, it's an item. Alright, so that works. So our state, the item actually blocks it, it removes the item, and if you actually want to see what this looks like, then I think we can dump that out. Bomb should probably have a countdown on it instead. No, it's going to be annoying to look at. Let's just assume it works. We have the states. So that gives us enough. Now we just need one more. Check if we are dead. Check dead. Let's give it a player ID. Which ID are we checking? I32. It's going to return a Boolean if the player is dead. And I'm going to do this. I'm leaving the bombs on the display because we're just going to check if they're within range of the characters. And oh wait, but that won't work. Because they're going to be blocked by stuff. And if I check afterwards, uh-oh, this is not good. So what we can do, we're going to add another state in the entity. We're going to add another state here. And now I'm actually going to have a new function because we don't care about these things too much. Because it's going to be harder to create them. We're going to have a state called, let's just call it, let's call it alive, for lack of a better term. Bool. Implement entity. I think that's correct. Implement state. Public function new we can just do this. What entity type? Owner-eye. This will be the generic I-tron I.32. I.2. Param1. This will be the one that the main entry points wants. Param2. It's an I.32. Does Rust have optional parameters? I've forgotten. My goodness, I've forgotten whether Rust has optional parameters or not. Optional arguments, optional function arguments, I mean. That sucks. Yeah, this is not helpful. Now, the suggestion to create different functions is totally fine if you have a language that lets you create a function with the same name with a different signature. But since you have to create different function signatures, you're going to have a lot of wacky names here. So this becomes entity, this returns self. What? Owner, position, param1, param2, alive, true. It starts as alive, and we're going to have to create a new one here for, probably for the, because what happens in the tests is I don't like now is that in the tests, because we have this new function, we can still create them this way, but it becomes confused because you're going to lose all that syntax. So instead of this, you're going to have new box 0, and the 0 is completely unknown. The point makes sense, and the two parameters make no sense anymore. It's not clear what they are. But we'll just do it this way for now. That is, I prefer the compound construction, but Rust doesn't offer a way to provide defaults in that compound construction. Nor do we get to use name parameters, so we're left with a situation where we're going to lose some clarity here in order to add some fields to our structure. Okay, we have that. We're going to do the same thing here. And this is what I mean, that there's no value in creating a second function that doesn't take these two parameters, because you're going to have to modify the name anyways. You're going to have to do like something like default p, and that ends up being more characters and no additional values added to that in terms of redundancy reduction. Okay, so we're going to have to change all of this some more. Simulator tests are going to have to do the same thing. Lots of fun, isn't it? I'm just focusing here. And we're doing this again because Rust doesn't have partial initialization. It's all or nothing. You can't just partially initialize the structure by named items. You have to completely initialize it. So there's no way I can do this any faster. New. But it looks a lot smaller now, at least. But again, it's a bit less clear as to what we're doing now because parameters don't have names, so this actually loses clarity. It's shorter, but it loses clarity. And I have no idea what I was doing all this for. It's totally lost track because we wanted this a live value. And that's in the simulator. That's what we have to do with state.entities. And oh crap! Now I know why we can't do it this way. Our simulator is going to be slow. Now we have to actually find the entity based on the position. Delightful. Can there ever be two entities at the same position? No. No, no. Okay, so we're going to have a second one here. Because we need to actually modify, we can't modify the cell anymore. Get entity at. And self. Now we'll use the Rust convention at mut_self and mut at mut_self position I.2 and mut entity, and this probably has to be lifetime whatever. And how do we do this now? There's a find by or something. Rust find by. Rust find by. Or just find. I hate looking through these things. I know there's a find in here. Find. Now, is it return immutable self? It takes immutable, but returns self item, but it doesn't seem to return immutable to that item. I'm reluctant to use this because I don't know. Again, the docs aren't. There's a lot of docs in Rust, but a lot of them aren't very good. I mean, they don't really say what we're supposed to use here. iter_find equals 2 sum and 2. It's like a reference there. Is it a mutable reference? I hope it's a mutable reference. And we're just going to unwrap it, assuming this is valid at this point. So self.entities.find, and because find takes a reference and many iterable references. I don't know what that means. Entity.position equals position. I think we implemented that. I don't know. Unwrap. Undeclared lifetime. I forgot how it does that. Isn't that how you declare lifetimes? was the end of lifetime again? Do we have anything that declares a lifetime again? I've forgotten the syntax for lifetime, so I haven't used it in a while. Or is it really just this one, like this? Yeah. Missing alive. This is an entry 31. This is also just going to be the whole new structure now. Again, we lose the information here about what we're doing again. Match entity type. This one is not so bad because we actually have the entity types there. We know what we're actually creating. There's only one of those now. Yeah. No fines. We're gonna have to do iter or something. Of course the types differ in mutability. No surprise there. Is there a mutable iterator? Cannot move out of borrowed contents, prevent moves. So why do we have a double iterator? Is this what it was mentioning in the docs? It's a reference to a mutable reference, I think. It is, and this is again. If you're watching this makes the language very hard to use. Like, I mean, seriously. I mean, an and mut, and then have to do an iter mut. This is just absolutely not friendly. I'm just guessing to figure these things out. I'm sure I could work it out in my head what this is, but it's simply not easy to use. You can't simply sit down and do high-level operations on sets and vectors and stuff. And it's something I'm going to consider very carefully when I do Leaf, how that works, is that when you're working with pointers and move and stuff, this type of situation can easily arise. But I hate this so much that I'll do everything I can to avoid this, because it's just not friendly, and it's going to cause errors. Because I don't actually know if this is doing the right thing. That's the problem when you have double references like this. I actually don't know if I'm doing the right thing here. Okay, and now let's go fix the one we want. We want to do get entity at mut. State.get entity at mut cfp.alive equals false. And we had to do it just so we can do this. And the same thing with the... We're going to kill the item as well, and this is also important. We're going to kill the item just so we can check that the item's been killed. And there's going to have to be a player here too. Now, players are a bit weird though. We're going to have to actually find them. We don't have players on the board though. Man, that sucks. How am I going to simulate the players? We're just going to have to search for the players? Well, let's just search for the players. Again, this is going to be really slow, and this is going to cost us a lot. We're going to have to super speed that a lot. And what we can do is we can simply say get player. Find player at mut and mut self. Position is an I point 2, and this is going to return an option of a and mut entity You know what? This is actually easy to just do kill player at. No, because we actually need to know what it is. Kill player at and reference a mut. Can't find player at mut. And this get entity is an issue now because you could have multiple entities in place. The player could be at the same place as a bomb. And so we're actually going to exclude players from this one right here. Entity.player. What? Equals, does not equal entity type player. We're doing this just because we want to find non-players, because players can, in a special case, players can be on top of a box, and otherwise nothing, everything else is exclusive, and this complicates it a little bit. So we're going to do a similar thing up here, find player at mut. Same thing, equals player type, player dependent position, and we're not going to unwrap it now, we're just going to return it. And see if we actually have that. Simulator, if we actually have the player at this point, if let's sum and mut player equals state dot find player at mut CFP. Player dot alive equals false. We're going to kill the player in this case. Yeah. I don't understand. Consider changing this to mut player, and it's already a mut player. And the option type is option and mut entity and mut player. I'm wondering what that is. What do we have to do here? Why do we have well, it's just not worth the effort trying to figure out what that is. Screw it. Option use size. Oh, we have this damn enumerate again. Any attempt to use enumerate is going to totally screw up the find. We had that exact same problem before. So just screw all of this. For I and 0 dot dot self dot entities dot len entity dot what equals entity type player and entity dot position equals entity type. No, equals position. Then we return I. Alright, we had to do. God damn it. Visual Code, just accept my stuff. I don't know what this is. I, self-entities I, self-entities I, self-entities position. Okay, so we return I. MTC, I don't know what neon is. I am running KDE. I'm not running anything called neon though. I'm just running whatever comes in Kubuntu 16.04. So we're going to return in some I. Otherwise, we're going to return none. This is a player index. What do I call that? Find player at. Now this is a really super slow way to find the players each time, but I I'm not worried about that right now. So just this, we can do self.state.entities player index.alive equals false. Did you mean player index? Let's just give it the full name because that sounds better. Alright, so it's still running, and the purpose of this was to check if the player is dead. We added a player somewhere. That was one of the critical things we need to do. We're going to add 2 players. It's going to be a player 0, and player 1. Player 0 is just going to be well out of the way. We don't care about him. And player 2 is actually going to die. He's at 1,5, and he should actually die at this point. So assert equals true state.entities, and these are added in order. So what is the order of this one? This is 0, 1, 2, 0, 1. Let's just give these things names. 0, 1, 2, 3, 4, 5, 6. 5 and 6. So 5 should still be alive. And 6 should be dead. That's the idea here. Not alive. 6 is now dead. Alright, so it worked. So this actually will give us the basis when we die. If we're dead, the score branch is really, really low. So now we actually want to do the code that walks through it. Wow, this is a bit hard now. I've done so much, I'm already getting tired from this. Oh, wow, it's been an hour and a half, and we just basically got the one-step simulator partially working, and it's probably slow. And let's see how we can do this, though, because now we need to have the strategy. We don't need a strategy test anymore. Get rid of this. Don't need to look at matrix looks. We can close that for a bit. Strategy. Now what do we have is we need to get the get best move. Public function. Get my best move. We'll just use the player index, and then we're going to give it state and state. It might be player ID, but that should be okay. And we also have to encode a turn here. This is the next thing I forgot. We have to encode a turn, and this is part of the simulator, I guess. Import simulator up here too. Use simulator star. And we're going to simplify this for now. We're going to have a public enum turn. And what does the turn do? What options do we have for the turn? Again, I said we have a lot of options. We can always bob at all of them. And I'm not clear what I'm not clear on how to encode this turn the best way. Whether the turn is just an enum with a flag on each item, or it's a multiple, or it's a simple structure. I think it's more of a structure. So there's an enum turn type. And this one is actually we might not need that, because when we output the turn, we don't care which position we move. We care about where they're moving to. So let's just do that. We'll just do position as an I point to, and bomb as a bool. This is a turn. And and we'll figure it out when we get there. And we also have to have not just a step state, but we have to have a public function apply turn. Turn, which is a state, and mut state, and a turn, which is just a turn. This has to be for a particular player, though. Should that be encoded in turn or not? No, we just give it ID. Player ID is in I32. And now what we need to do is we need to get the player first. I think we have a get player, find player with an ID. And we just assume it exists. Let player equals state.find player. And this gives a copy of the entity, which sucks. Find player. Let's do an index instead. I'm not going to attempt to iterate. I'm going to just do it the other way. What do player and self.players.id. So ID. Return I. No player found. And this is an I32. This is a U size. This is the index of it. Find player index. Player equals find player index at player ID. Again, we do all this because you cannot have multiple references within the state, and if you watch some of my older shows, you'll get my impression of this. I really don't like this. It makes a lot of these algorithms really hard to do. A lot of this code here is we're actually not doing the code I want. We're just working around a limitation in the borrowing system. So we have player index. Good, we have a player index, and we want to apply the turn now. And we're going to blindly assume that the turn is valid. And that lets us do state.entities player index.position equals turn.position. Before we do that, we're going to do if turn.bomb. We're going to do state.add entity. I think it's called entity, add entity. State.add entity, entity new. We're going to add a new bomb with a dropping a bomb. And this is an entity type bomb. The owner is the player ID. The position is, this is the one down here again, this position. The player's current position, that's where we drop the bomb. And where do what type of bomb do we have? How do we know? Well, we have to check the parameters here of how big the bomb can explode on. Two, the explosion range of the player's bombs. Perfect. So we don't care about this one. No, that's the bomb will be, yeah, that's, we need to have, and again, this thing here, it's just really annoying. I copied it accidentally. Yeah, that's fine. Parameter 2. Explosion range. And the countdown is always the same. So the countdown was 8. Just 8. I'm just going to put 8 hard-coded there. And so we apply a turn. So now I actually have to go into the state and apply a turn simulator. We're going to create another one. Apply turn to test this stuff. And we'll just leave it empty to start with. And we're going to say simulator I guess I have to add a player to it though first. State.add entity, entity new, entity type, player. Let's give him player ID 5. Point 2 at. Let's do 2,7. And how many bombs? You can place 1 bomb just in case. And its current range of the bombs are, let's just say, 4. Okay. So we're going to apply the turn to the state and mut state, and we're going to do a turn, which is a position, and we want to do an I point 2, 3,7, and bomb is true. That's the turn the player is taking, and this is player 5 that's taking this turn. So now we're going to assert equals and make sure everything works. So we're going to say cell type bomb in state.grid.getXy, and it should have been placed at 2,7. And it should be, the countdown should be at 8. And state.entities1, where the bomb is, .param1. And that should give us enough information that the bomb player is there. Oh, and the position of it, assert.equals, where the position player is now, I point 2, 3,7, state.entities 0 dot position. Did you mean state? I probably did. Did you mean state? Yes, we did. Entities dot ID owner. I guess it's owner. Or we can click on this sometimes. Alright, so what's it bitching about now? Oh yeah, we've had this problem numerous times. This is actually recognized as a defect in Rust, at least. That its borrowing rules survive beyond the end of the program evaluation. I'll just stick this all in one line. Yeah, okay. And let's do simulator turn here as well. Did you mean I point 2 fields? Yeah, no, yeah, no. At. You know, it's just taking longer and longer to compile. It's kind of bothering me. I don't know if that's good or not. Public. I'm going to derive some stuff here too. Clone, copy, debug. And these should also probably have partial equality. They can be compared. Function is never used. Apply turn. Now that kind of bothers me. What did I do wrong? I forgot to mark it as a test. Alright, so the apply turn actually worked. So we have a turn there as well. So we basically got the turn and the state, and they can step through it. So all this effort was so that we can mimic what the game is doing when it steps a turn, and we're not quite completely there yet. And I imagine as we keep doing more and more games on Coding Game, this aspect of it could actually end up getting a little bit boring because it's always the same thing. We always have to apply the state, we always have to do this, and it's always this and that. But I guess that's part of the challenge there. It's one of the reasons why I might not do the competition though, because there's a lot of stress to get this done in a lot of small time. Alright, so we have a test, we have a simulator state. Now we want to go back to strategy. That was the whole purpose of this. We want to have a strategy called Get My Best Move. And it returns a turn. So how do we do this one? Wow, this is where we set up the recursive descent now. Not the recursive, the breadth first search. We're going to set up the baseline, get a current score, and get the one that gives us the biggest score. This is going to be a problem that our scoring is going to have to consist of more than the game score itself. Because if we only search 4 moves in the future and we place a bomb, it won't have time to go off. We have to go 8 bombs. We'd have to go 9 steps in the future at a minimum to get anything. So our scoring is going to have to calculate how many bombs, how many boxes might explode, which makes us even slower then for the state to calculate the current score. So this is where our bottleneck's definitely going to be. In retrospect, the actual cloning of the state might not be an issue. It might actually be the applying of the turns and calculating the score. And this is going to be what kills us the most, because this is really complex what happens calculating the score. So, what are we going to do? We're going to have to say something called best turn. And we're going to have to give an option of the available turns. And I'm trying to think of how we do this without being redundant. Let's just see if we can go 1 turn first. Let's do a 1 turn thing and see if it helps us in any way whatsoever. And it might not be enough to do 1 turn. Screw it. Alright. Let's just set up the outer loop first. Let best turn equal none. This has to be immutable. Immutable best turn is none. Best score equals 0. It doesn't matter because we're going to check best turn. 0. And we're going to test a variety of moves. And this is where turn having a hard-coded position may not be the best option. But let's go to the offsets again. We had offsets here. So we have offsets here as well. Offsets. We're going to do this way. We're going to do offsets, and then we actually have another offset here called I point to x0, y0. Let and offset in offsets. No, wait, turn offsets. And we're going to try placing a bomb in all of them for now. And this is actually explodes a lot faster than we want. But maybe if we just go 3 moves in the future, that should be fine. I do not know. I do not know how to do this one. Alright, let's just check this. So we're going to say the turn equals... Let's figure out where the player position is. Player is equals state dot find player. And find player is an I32 state.myId. And we should be able to take a reference to this because we have the player. Doesn't really matter. This is all read-only anyways, I think. And next position, we're going to say let next position equal player.position plus offset. And then we're going to check the validity of this, whether it's a valid free position. And how do we do that? Should we put it directly in the state or in the grid, or where should we do it? Let's just put it right here. Function is valid move, state and state, position I.2. This is a bool. And this will be a match. Alright, so if it's out of it, so we have a matrix, first of all, we can say that if the moods, we have a def get on the matrix. That's what we did before, so we can simply say match state.grid.get def position cell type wall. And that is if the position's off the board, it'll return an invalid index as well. And the only place we can actually move, there's only a few places, cell type item or cell type empty, true, otherwise false. So the only two places that we can move to. And so we say if not is valid move state, comma next position, then we continue. This is an invalid move, we just drop it out of the way. And now we have to do scoring, we have to drop a bomb. We have two options for each of these moves. We drop a bomb and move on, or we don't. And so we're going to do so for bomb in, and this is where it does something silly. Bomb in true, comma false. False, comma true. Let's do it this way. And we're just doing all the moves to start with right now. Alright, so we're going to say let dupe state equal state.clone. This is the very costly way. Let mut dupe state. And now we can say apply turn, dupe state. And we need to create the turn first of all. Come on, why do we create the turn? Let turn equal turn position next position bomb bomb. I guess bomb works on its own. Apply turn turn. And this has to be a reference to turn. Has to be a reference to the mutable reference to the state. And then we're going to step state and mut dupe state. And we're actually going to call this in one of the tests just to make sure the compilation and stuff's working on this. We don't actually care what the real value is here. Good bomb, too good bomb. Let's just start with something simple again. Where am I? I'm getting confused. Strategy, get my best move. So we're going to add a player. Player 6 at position. Let's just add him at 3, 4. And he has one bomb and he can do a range of 4. Let's just say that. And we're going to add a game box at position 4,5. And we'll add a bomb at position 3. Let's put it right above us. That should test a lot of stuff. Right above us, 3,2. 3,3 is fine. And this was the range. It has a range of 3, and it's going to explode on the next turn. And so let's turn equals simulator get my best turn for the state and player 6. And we'll just debug this one for now. Turn. Though we know what the turn should be. It should actually walk to the right, and the next turn after that should drop a bomb. This is what the goal will be. In this little setup here, our best move is to drop a bomb. And we'll keep playing with that for a bit. Just check the compilation first of all. Pub function, get my turn. Can't qualify my approach from pub. Alright, that's because I called it wrong. Pub fung. Let's turn offsets. It's 4. I don't know why I put let's. 4. And we have expected 3 parameters. Apply turn. It needs the player ID. That's correct. Unknown field. This is the owner. Sorry, it's not the ID. Weird. Apply turn. Oh, it took a copy of the turn, so we can just give it the copy of the turn. We don't care. Oh yeah, I guess we actually have to finish this function first. We need to score it somehow. Get score, state, and state. This is an I32. Just say 0 for now. It's going to be something weird. Hello, Piano Master. Welcome to the show. We're just trying to write we wrote the simulator for the Hypersonic, and now we're trying to write the depth first search, getting a score, get score. And this would be a one move thing in the future. And I think one move is going to be enough for us to actually do something. And I actually want to get it there first, get score and do state. If best turn equals none, or score is greater than best score. And you'll recognize this loop from like basically every single game we've done. Turn best score equals score. And we're going to return best turn.unwrap. There has to be some valid move. If there's no valid move, well then you're screwed. Right? This is in where strategy tests. Strategy. Should get my best move. Really, it shouldn't be called get my best move. It should be called get my best turn. Expected 1 parameter. Get my best turn. Because it already takes the ID of that, which means we better state.myId equals 6. Alright, so we can actually get my best turn now. It does nothing because the scoring's wrong. So they're all going to be scored entirely randomly. Let's actually print out what it does so we can at least see the output. Piano Masters, I'm trying to reserve my judgment on this, but my impression so far is that Rust is not a good language for embedded programming. It's too hard to work with state. It has all these boring rules that every time I've done low-level programming, it's the exact type of stuff you want to do is exactly what Rust is preventing you from doing. So I haven't figured out the field where Rust best applies yet. I mean, it seems to apply somewhere between low level and higher level. Maybe if you're doing a lot of... I have a hard time yet. I mean, I don't know the place where Rust best applies yet. If I had to do embedded, even knowing the Rust right now, if I had to do any type of embedded programming, I would still choose C++ first. And obviously C if it's not supported, but C++ would come first for me because it's still, again, I know it better, but I have this odd feeling about how Rust works. And I'm trying to learn more of it, and the borrowing system, I'm fighting it too much. I'm fighting it to do a lot of basic algorithms, and a lot of the comments have been, well, you use unsafe blocks, and to me it's basically, well, that kind of defeats the purpose of the language if I have to put the stuff in Rust. And Piano Masters know, other than this show, I do not use Rust. I'm just learning this because I have my own language, Leaf, and I'm trying to learn from a bunch of different languages what the good things and the bad things are. And there are a lot of nice things with Rust. It has a lot of nice pattern matching. Pattern matching is one of the nice things. In theory, its performance should be quite high due to its borrowing mechanism standard by moves. And the thing that actually gets my way the most, the borrow checker, actually shows a lot of promise for actually making a safe type system, a safe programming language. I don't think it's there yet, though. I think there still has to be more done. There's still a lot of weak ends to how using this. But I think it does show potential. I definitely want to learn all the ins and outs of it. Alright, so where was I? I wanted to figure out how I... cheat sheet. Man, I forgot to update that again. How do I not capture the outputs of Evening Rust cheat sheet? Where the hell am I putting these things? I'm looking for the way to run the syntax now. I'm trying to capture the outputs. Completely forgotten where I put the cheat sheet. We have a command reference for the commands I often use. Where'd it go? That's weird. I'm positive I had a cheat sheet which showed me some of my files. Hypersonic. Is it here somewhere? No. Is it in the README for some reason? Oh, it's in the README. Why would I put it in the README? That's just silly. Cargo test strategy -- no capture. I want to see what the turn says. And I'm not sure why it printed all that out. Get my best move. Get my best move should have printed out one turn. Why is it printing out? Piano Masters for machine learning. I don't know yet. I've not looked into machine learning algorithms for it yet. I know Python's still at the front of the game for machine learning. In theory, I'll eventually get there because we have a few cases to use machine learning in this code. We have a few cases where we have to do, but it's only going to be little neural networks, so I don't know about the standard machine learning scoring, partitioning, and stuff. I just don't know about that. It might have it, definitely not in the standard packages, but there is a crate system, and this cargo system it has. Cargo is like if you were using Node, like npm or pip for Python, and apparently the cargo system is really good for patching stuff and grabbing it, and they have a very active ecosystem, so you'll probably just have to look. There might be some good stuff for machine learning. Certainly the threading is very good. There's lots of ways to do threading, and if you have to do lots of evaluations, it might be good for that. We've used it in one of our previous games, simple threading to score things in parallel. Alright, so why is this outputting 4 things? And why is it not outputting the turn? Turn's right there. Okay, so the other ones are up there. Boxes within range, 2 good bomb. 2 good bomb is outputting stuff. Piano Master, as I said, I do not know yet. I have yet to find a domain where I would recommend Rust as like the primary choice of language. I still don't know. I have yet to find, after these few months of work, its primary advantageous state. If there's stuff in the containers, obviously compared to C and C++, this container system is really strong. But otherwise, I'm still working at it, trying to figure out where I would recommend using Rust. Okay, where the hell is this output coming from? Is there an ePrint here somewhere? ePrint. Right there it is. That was in 2 good bomb. Let's get rid of these for now. I think I don't even need these functions. I can probably just remove these functions at some point. So turn, we're going to do it at 4-4 and bomb false, and that's just the first throw ahead. And so now we have to change the scoring because there are some things we shouldn't do. And this is where the scoring function comes in. Now we actually have to write a scoring. What is the scoring as opposed to just a score? Get rid of the simulator for now, and strategies over here. So we have to write this function, the score function right here. We have to know what our player is. I think we have to know what our player is. So obviously, if player alive, if the player is not alive, you're just going to do this. So you're going to return standard I32 min. Player's dead. This is a bad move. This is the utter worst move. It's just the end of the goal. They're dead. Don't go this way if the player is dead. And we're probably going to do a special thing, pruning on that. Because the player's dead, don't even go in that path. Now the next one would be player dot or state.myscore. But this doesn't look far enough in the future as to what happens. But this would at least eliminate the one where we go to the dead stern. But we're not going there right now, because 4-4 just happens to come first. So we still don't have a verification. So instead of doing it this way, let's add the box at 2, 5, forcing him to go in the other direction instead. And we still move to 4-4. So let's also put a bomb at 4-4 to at least, or 4-3. wait a second. How can the player... Yeah. So player moves to 4-4. No, there's a bomb at 3-3 that's above him. And there's also a bomb at 4-3. Let's put a bomb at 4-3, which should in theory prevent him, if we did this right, should prevent him from moving to 4-4, because that gives him a really bad negative score. Alright, and so he doesn't move to 4-4, so at least we have some indication that our logic at least does something. It prevents him from walking into a bomb which is currently on the board. He'll prefer one that's not on the board. But we'll never place a bomb still because there's nothing there. So what we have to do is we have to go through all of the bombs. And we have. And since we're going to say my score, we're actually going to say my score times 10. Well, let's figure out the bombs first. Let's figure out where all the players' bombs are. How can we do this? We're going to duplicate what the simulator does for the bombs. All of the bombs, all of the bombs. Now we can actually do the filtering. It's easier this way. We can do state.entities filter entity entity.what equals entity type bomb, and entity.owner equals player.owner. This will actually give us just the bombs, and in the non-mutable mode, these filtering and map functions work just fine. And how do I want to do this now? Let's just do this in a loop. For bomb in filter, and this probably needs to be iterated. Stupid visual code. And now we want to say boxes within range of this point. Boxes within range. We'll reuse that function, and we think this is correct. Boxes within range. This is getting very expensive, the scoring function, which is really bad. So we're not going to call it very often. We're going to call it in the leaves of our trees, not at every start. So let's just say let mut score equal state.myscore, and we'll give current score a score of times 10. And then we'll say score plus equal boxes within range. Within range, and this takes a and state. And what do we say? This is the player position. Player dot bomb dot position. So any bomb that's going to be exploded, or any box that's going to be exploded by this bomb, counts towards a minimal score. So our main score is 10, and potential score counts up slightly higher. So where do we go now? We have an error there. Forgot to put a semicolon, that's going to screw everything up. Okay, we still don't place a bomb because... Why don't we place a bomb? Did we allow... Should the test have placed a bomb? Where are the boxes? Boxes are at 2, 5. So yes, we'd actually have to go 2 steps to place that bomb. But you know what? Let's just have fun and let's see if it actually does something. Let's see what it does. If it fails on us, or what does it do? Oh, we haven't actually updated the main code yet, so it's going to do nothing. So we better fix that first. So get best move. So entry no longer says near box. Just going to remove this. We're going to keep it's called near box, but it should be best move. Next move equals... Did I import strategy? Yeah. Get my best turn. And state. And we'll see what that says. Next move. No, we don't need to do that. Get rid of that. Next move is position... No, this is totally wrong. Next move, next move. Yeah. If next move dot bomb, else print line bomb, and then to the next position wherever we go. Next move dot position dot x, next move dot position dot y. I just want to see it do something now. We've done so much work today and it hasn't actually done anything yet. We don't actually have any look ahead. We're doing like a one-step thing, which is obviously not enough to help anything. But hey, we might place a bomb. Maybe, maybe not. He might also run around like an idiot. So, run around like an idiot seems like the best option there. But he is running around, which is a good thing. I'm wondering why he doesn't place a bomb ever. It has to be something with the scoring. Something with the scoring. We have to be placing a bomb somehow. Like right here, he should place a bomb and... Why not? Why do we not place a bomb? So we can test that in our code, and we set up the strategy that we have. If we put a game box directly beside him, he should place a bomb. So at 3,5, we're going to place a box, and we expect him to place a bomb there. Bomb false, so it's not getting that. So why is that? That's the scoring thing. There's probably something wrong with the score. So we apply a turn, and we get the score, and let's see what these scores are. ePrint line. Turn, we're going to do a turn output here, and this becomes a score to be turn, and this is the score. Let's figure out what we do. Well, it shows we die with the bomb. Why would we die with the bomb? Well, we know those both do. That's the bombs going off. And the next two... Do we have two bombs in the test? 3, 3, and 4, 3. Yes, we have two bombs in the test. And so moving 2, 4, could just go to 0. 2, 4 with a bomb is true. And why does this give us -1? That's the stupid function that has... Where's the last result? So this should give us more of a score. And that's because boxes within range, -1 if on a box. So we're doing something invalid there. It shouldn't even skip there. So there's something wrong here. If this is the position. Alright, now let's look at our map again here. Let's look at what map we have. We can do state.edump. And look at what our map is. Ah, how do I run just the one? Come on. It's annoying me. I know we had that before. Get my best move. Anybody know how to run just one test? And in sequence? Rust, run just one test. Rust, cargo, I guess, cargo. Let's just say cargo, run one test. I lost my chat window. Zaglev, no, that's running my entire test suite. So I have cargo test dash slash test strategy, but I have 3 tests within that module. I want to run just this one test function, not the whole set of them. Keep this on top. It is above others. Wonderful. I had just tried that, Zaglev, yeah? Watch. Test get my best move. And it says there's no test target, name that. The dash dash test there is. Oh wait. What does dash dash test do then? Alright, so there's 2 different rings. There's a test and a dash dash test. I don't know what the difference is. Okay. So what does our board look like? We have the player, and we have 2 boxes, and we have 2 bombs. So something's wrong here. That looks about right. The bomb's going to go off right away. And do we apply my turn first? We should. We apply the player's turn first. And then we step the state. Well, let's dump the state on each of these. Dupe state.dump. edump. Alright, move 4, 4. And that goes away, yes, because it's destroyed the box. The other bomb does. Bomb true. Don't know why this one's returning -1. Something wrong with that function. What's wrong with this function? Why would it return -1? Empty position. Print line. Here. I figure out which one's doing that, because that's broken. Bomb. There's already bomb at there. 2, 4. Oh yeah, because why did we exclude that? Well, I don't care. We excluded that from the previous one for some reason, but I'm just going to remove it now because there's no reason. We're calling it in a different context, and it should be fine. So we placed a bomb, but the other bomb has already destroyed it. That's why we don't have any scoring there. The other bomb already destroyed it, so let's up the bomb count to 2. And the other one to 1, so he doesn't walk there. Then we should at least see a bomb. Place the bomb. Come on! 314, 2,4. It places a bomb here, and that should give us a higher count. Why is it not giving us a higher count? It's placing the bomb correctly. Even 3,4 placing a bomb should give a higher score. Why doesn't it give a higher score? And that's this boxes thing. It has to be in here somewhere. All the entities. If it's not a box, that's fine. Entity position is here. It's good. Good. Bomb range. We'll gotta cancel this hard coding, but we're still within range. Wait, this has to come before. So we're going from the box. Yeah, and I remember why we changed that before. Because we're doing something stupid, but the old strategy we don't care about anymore. I'm going to remove the old strategies in any case. Right, so one of these, okay, so that one drops a bomb, we get a 1. We get a 1, so we get a couple moves where we have a 1. There are bomb moves where we get a 1. And it can't decide whether between moving or not, and that's totally okay. Cargo build, that gives us at least something. Let's see if we drop a bomb. And we took too long. Oh no, we failed. That means we have a file without a line feed at the end, generally. Uh-oh. Alright, what do we have here? That has one. Shit, what's the problem now? Where's 118? Oh, our bundler is doing something weird. Function main. No, 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 that's bad, bad, bad. Let's open up this single file, figure out what it's complaining about. we can upload again, and occasionally it just screws up. Alright, that was one of the cases where... Alright, so we clearly don't look far enough into the future. Oh, man. Because we don't look far enough in the future, we don't see that we're in danger. And this is something Petrosol said. He just said, anytime you're in line with a bomb, he just decided that, look, I'm in danger, it's a bad position. And we can basically do the same thing, just don't put bombs in it. And how can we do that easily? Easily being the key word here before I get too tired. And that has to be in the scoring. And so what I mean basically is that because we don't look further down, if we're in line of a bomb, we should basically say, look, that's a bad score as well. That's a bad idea. And can we reuse something? Boxes within range. It's going to be the same basic thing, bombs within range. Get rid of this nonsense. We don't care about the comments there. The other strategies are basically destroyed at this point. We don't need them anymore. And what can we do though here? Can we reuse this one to find what type we want? We're looking for a game box. Within bomb range. I guess we could just look for a particular entity that's within the range. Yeah, we can split this up. Basically, if entity within range, state and state to I point to entity and entity Boolean. Why did I just give this the name? Function entity within range is a bool. If entity within range, this should have the bomb in the name somehow. Then we have and state. No, it's already a state. 2 is 2, and ent. Count equals 1. I'm just wondering, should I totally destroy our previous strategy, or do we need to know this again? Let's refix this a different way. Let's keep the old one in case we need that old strategy some more. I'm gonna put this back in. Take out these things. And this goes back the other way because this was the old one. And now we're going to change it and give proper names to these things. We'll just get rid of this old one. This is deprecated. Deprecated. And let's do something here at the bottom called boxes within bomb range. And actually we can just do entities within bomb range. I point to, we need an entity type. What is an entity type? Actually, no, that's not what I want. We'll just say boxes. So yes, we don't care about the bomb. It's not a box, we continue. We don't care about this. I don't know even why that was there. And it's the correct position, it goes here. And we return the count. Okay, but we can do something simpler. We're going to simplify this and go if entity is entity within bomb range, and that's the bomb 2, and we're going to do an entity is an AND entity. This returns a Boolean. Let's see what we get. We're going to copy some of this stuff out here. Yeah, that's a short circuit one. It's not the same Y of different percentage, 2%, gender percentage. Turn true. False. And here we say if is entity within bomb range state 2 and entity count plus equals 1. Now that we have this separated out, we could probably do a filter and sum on this stuff, but let's just do it this way. And noise scoring as we have boxes within bomb range. And we do the same thing if is entity within bomb range is entity within bomb range This is not going to work though, because he's not going to place a bomb ever again, because the bomb's always going to be within bomb range. We might have to go a few steps down. Right, we might have to set up the recursion, but the basic idea is going to be this. If bomb is a range state to player dot No, I have this backwards now. Oh, okay. Okay, I'm too tired. I'm going to have to get back to this tomorrow. I'm going to have to get back to this tomorrow evening. I can't. The idea here is we're going to have to check it, but there's no way. I thought I could do something quickly, but because of the bombs, we're actually absolutely going to have to do at least a few step tree. Otherwise, we're never going to place a bomb safely. So I'm going to leave it like that for tonight. We basically set up the simulator. We set up the basic strategy. It doesn't work yet. We're going to have to set up the recursion. And we'll have to consider the bombs where we place them. So I'm going to leave it at that for today. I think I've got far enough in Leaf that I can start the game programming tomorrow, and I'm going to see what time I do that. If I do that long, I might not do this. I can do that early. I'm not sure, but tomorrow definitely I'll be doing something. Hopefully I can start the game programming tomorrow or on Saturday. And the game programming leak, we're going to do the Tron game that we did a long time ago. I'm not far enough to do this game yet in it. And we'll catch up, and it's going to be an adventure in compilers, in OpenGL, and SDL, and algorithms, and basically everything, because we're starting from scratch. We don't even have a working compiler. So it'll be a lot of fun, and it should be very challenging, and I think I'm going to leave it at this for today. Thank you very much for watching, and we'll see you again tomorrow.